Nice to be here and nice to see you all. Last session of the day. Who had a good summit? Maybe raise a hand. Yeah, awesome. Me too, really excited. A colleague of mine told me you're last for the day, so you're like the headline. So that's why I'm here, right? So we flip it around a little bit. Anyways, my name is Joachim Sederman, and I'm going to talk to you about how we built a data lakehouse for autonomous driving. And to set the stage a little bit, we've been working with Databricks for 3 years now. Before that, we did a lot of our stops on like laptops, on like on-prem compute infrastructure, which couldn't really scale. And now we're here 3 years later, and a lot of our users has really 10x themselves in terms of what capabilities they have access to. So that's really nice. So I'm going to share a little bit that story and the problems we have run into, how we set stuff up, and what our future plans. But before that, just some commercial. For you who don't know what Traton is, Traton is a heavy-duty kind of group of different brands. We have Scania, MAN, and also Navistar, which I guess is very popular here in the US, and also Volkswagen Truck and Bus. Last year, we sold a bit over 300,000 vehicles. We have a bit over 100,000 employees and 33 sites worldwide. So quite big. But I'm part of the R&D organization that works with autonomous vehicles, so that's pretty much what I'm going to talk to you about today. And autonomous solutions for us, we believe it will have a really big impact on transportation as a whole, both in terms of it being more efficient. A robot is a better driver than a human, but also it would be more safe, and also hopefully maybe here in San Francisco and California reveal some congestion issues that you might have. So I think this is really going to transform how we do transportation. And for us, we have two main kind of business areas. It's mining, and mining is all about round-the-clock safety. And when we talk to our customers, their safety is paramount. So here, really, a robot can perform better. Then we also have hub-to-hub, which is a logistic hub to a logistic hub. So really this kind of transportation where you try to get goods into near cities and other areas. So that's something that's really exploding lately as well, which we're working on. And just as you know, you will see a lot of pictures of truck in this presentation, so I hope you like that. But here's one of our trucks for the mining business unit. It's taken outside Channar in Australia. So challenges we have here, for instance, is it's very hard to get good connectivity here. So how do you get data back to the cloud so that we can provide to our end users? And then we have the self-driving on the public road, so called hub-to-hub. And what you can see here, although we still have a safety driver, the hands is off the steering wheel, which I think is kind of cool. So we were actually first to get the public road approval in Germany and Sweden when it comes to these big, heavy trucks. And the way we had to do it was to actually do we call it uppkörning in Swedish, but it's like a driver's license test exam. So we actually had to go there with the officials to show how it works. But so a little bit background for what I do, but today I'm going to talk about what we do in Databricks pretty much. And the key for us when developing these type of capabilities is getting a lot of data to train our models. And the way we approach that is that we set up this data and AI loop, as we call it, which we gather the data from the fleet. And on each kind of vehicle, we have around 16 cameras, 8 LiDARs, and 8 radars. This data is then offloaded using hard drives today because the data volumes are so big. And then using different type of edge locations, we upload it to the cloud. And there we either experiment with new models or we fine-tune the existing models that we have. And then when we see a measurably better performance, we deploy it back to the fleet in conjunction with some new triggers for new data that we want to collect. And the type of AI capabilities we develop in-house is the ones you normally see in the kind of robotics field. So we work with perception, so being able to see. Here we have different type of models that work both based on 2D but also 3D. Some ones are, for instance, semantic segmentation and doing road features. But then lately, maybe you have heard about multimodal for like GenAI, but we're also working a lot with multimodal data sets for instance, for object detection, so fusing LiDAR and camera. But then, even though perception is the biggest area, a lot of research and experimentation is also being done in the prediction and planning area. And here it's more about being able to understand what are other actors in the surroundings. So let's say a human or another driver, what are they doing? And then plan based on that where we should go. But in addition to that, we're trying to empower ourselves by improving our tooling. So both in how we can verify the whole system, but also how we select and augment data, so we can even further improve our models. So now it maybe sounds like we have come quite far and have a good kind of ideas in place, but the challenge here is that it's a problem you cannot really solve. You constantly have to work with gathering new data sets. So the notion we have is that we want to set up this kind of flywheel mechanism. And I think they mentioned it in the keynote in the day too, that you want to have a mechanism so that you constantly collect new data that you curate and then push to your data, to train your models so that you can handle stuff like data drift and whatnot. But this comes then with its own set of challenges. Saying that let's be data-driven, that is also hard. We, for instance, see that it increases the complexity of our data and ML tooling. Also, we see a very big growing infrastructure, and also being able to handle the competence and the knowledge for doing this. And I don't know if there's some other big enterprises here, but I would imagine many can recognize in this set of challenges. And I think this picture from Google and their famous paper, Hidden Technical Depth in Machine Learning Systems, really kind of summarizes the challenges very well. We want to focus on the functional aspects, the AI code, but there's so much around it that we need to manage, making it very hard. So what the approach we have then to try to tackle that is apply some type of platform thinking. This is nothing new. You probably read about it in the famous book Team Topologies. But really what we want to do for our data scientists and machine learning engineers is to simplify all this complex technology that they have to learn and maintain and reduce their cognitive load. And by doing so, we want to offer nice self-service data and ML infrastructure so that they can do their work without having to know everything surrounding it. And what I think has been key for us is not only to just say, hey, here's some tool, go and do your stuff. We really co-develop and work very, very close with our users. So co-development is a term we really try to become like a culture in our team. So referring back to this picture from Google, all this complex stuff around, we want to make that simple and kind of go away so our developers can focus on the machine learning code. And a big part of this, like this kind of platform that we offer, is Databricks. And a key part of that is Unity Catalog. And I would imagine many of you know what Unity Catalog is, so I will not go through that. But we use it for discovery, having a common place for access control, creating data governance, best practices for users, but also how we share data. And we are quite big organization, but not that big. So we try to set up some basic kind of structure around how we deal with our data. And those are these different catalogs you see here. So one of the catalogs that we create is, for instance, when we onboard a new team, is the so-called team catalog. And this is pretty much the area where the teams can do what they want. They can create their own tables, volumes, models, dashboards, whatnot. They can segment it based on, is it dev, staging, or other type of workloads that fits their use cases. The second one is the sandbox catalog. So we can't yet kill Hive, but what we're trying to do is to have this sandbox catalog as the default catalog and be a place where we can, where our users can start and just play around. And all of the assets in here we clean up every night. So we have a job that goes in and just deletes what is being created there. Then we also have this notion of the personal data catalog. Here is where we have all our GDPR sensitive information. For us, that could be like GPS positions, it could be license plates, human faces, and things like that. And this is a more restricted. Has only people who is part of this kind of personal data group has access to that, and it's a very subset of people in our organization. And then we also have the data share catalog, and this is not to be mixed with delta sharing. This is more a place where we have data which is of high value, but not necessarily curated on Databricks. So it could be, for instance, open source data sets that our developers want to share, but also other type of system outputs, like from our simulator. And then, last but not least, we have our data products catalog. And this is pretty much the place where, like our place where all our developers go to pick up the data sets for the different use cases. We have, for instance, refined data sets from our sensors from the fleet, label data from our annotation supplier, also other type of system data, like application logs and something called DDS, but that's pretty much very like autonomous vehicle specific data sets. And by default, this catalog is like open for everybody to make it easier for them to get access and get going. So that's pretty much how we utilize Unit Catalog in a nutshell. Then we also have so that's the data, but then what you do with the data. So our typical kind of development flow for our ML engineers looks like something like this, where we have created our own kind of training framework based on PyTorch and TensorFlow, which we have Dockerized, so that our end users can both develop locally if they want to experiment something, but also take it up to Databricks and the cloud. We leverage mostly the cloud for like access to instant access to a multi-GPU setup, so that we can train and validate and test our models. Here we also connect MLflow, and we use it to track the metrics and other type of artifacts that we get from our process. Then once we have a trained neural network, we convert it to NNX, and that's pretty much the format we store and register to Unit Catalog. Then we have a bunch of different pipelines who does different check depending on what it is the kind of the intended workflow. But usually we have some type of contender versus champion being done, and the one who then gets promoted, we convert that model to TensorRT, which we then deploy to the actual target hardware on the fleet. So both with that in mind and also how we store our data, we have this notion of our kind of autonomous vehicle lakehouse architecture. And it's quite big and maybe daunting, but it's pretty simple. So let's just walk through it on a high level. I think it consists of three main components. You have the fleet, like uploading data to the platform, but then also deploying the models back to the fleet. You then have all our different users. So we have our functional developers. They are ones who are like a bit more C++ savvy. Maybe we just want to check some dashboard and do some simple exploration. We have our, what we group together here, our data engineers and data scientists. They build pipelines, create dashboards, and are more assisting the different ML engineers. And then our ML engineers, they are the ones who actually develop these different type of neural networks and create pipelines, experiment, use all the different capabilities for Databricks. But the way everything starts, you see we kind of try to follow this notion of a medallion architecture where we have the bronze data, the silver data, and then different type of gold data sets. And this is kind of how we think about our data as we improve and curated it over time. But the way it starts is that once data is uploaded to S3, we use autoloader to read in all the different files that we get. So once we have validated that the files are, for instance, not corrupted, we extract the data into Delta. Then we have a set of pipelines that anonymizes for instance, the images and the point clouds from our LiDAR. And then we have what we call the kind of silver data set of our sensor data. And it's really from here all the magic starts. One workflow is that we have our data engineers who have created different types of pipelines. This is very oversimplified, but it's a notion of how we prepare our data sets for training. What we do here is that we have a simple kind of model. So for the clustering part in the data preparation, we have a simple model that we run to get some simple features, which we then use to cluster together and sample out like one image, for instance, out of all the different images we collect. Then when we have done this kind of subsampling, we run it through our different type of inference models. And these are usually just larger DNNs that are optimized for higher accuracy and can take longer time to finish, rather than the ones we have on the vehicle. And then we get a notion of our both selected gold data and also our kind of auto-labeled gold data. But then there are certain instances where our models have a very low uncertainty, a high uncertainty for what it can see. And for those images, we label them. So we send them to a third-party annotation provider. And once we get that back, we then have a set of manual annotations. So this is then it's called a smorgasbord, like a smorgasbord, I think, of data that our developers can consume. This is then all kind of managed through Unit Catalog. And as you can see here, I just managed to get the new icon for Unit Catalog. So I was kind of proud of that. So that's now part of this picture. But then from Unit Catalog, our developers can then go in and access all these different data sets. As I said before, a big part of this is just understanding our data. So we have a bunch of dashboards. We do data exploration. We have also built different type of 2D and 3D visualization tools so that we can view the images and the point clouds directly in a notebook. But then we have our ML pipelines, which is a variety of automated pipelines to train the models, to evaluate them, and then register them back once we get kind of new data and want to retrain. So that kind of, and once we then have a new model, let's say, we then have another set of systems so that we can pull in that model and use CI/CD to push it into the kind of bake it into the application that we then deploy to the truck with all the other type of capabilities we develop. So that is pretty much how we then get data, we curate the data sets, make it available for our developers, and then they can do their magic. Another part of this, as I mentioned Australia, but we also are targeting to operate in US. So today we work only regionally in Australia and Europe, but we are currently working with going multi-tenant. And here is another key for us using unit catalog, that we can set up this kind of multi-regional based infrastructure. And the kind of principles behind this is that maybe you've heard of the notion of data gravity, but for us that means pretty much that we don't want to move the compute. We don't want to move the data to where we have the compute, but rather we want to move the compute to where we have the data. So instead of like shuffling all the data all around the world, we want to have kind of edge locations where we kind of offload our data sets. Then there's also this all the different laws and regulations that we have to respect depending on where we're out gathering data. For instance, when in Europe, every single country has their own kind of local rules and regulations that we have to respect. So that's something we foresee will happen more as well in the future. So kind of core aspect here is that we haven't yet understood if we want to centralize all the data or have to have more like regional optimized models. But with this type of setup, we have the capability of doing both, which I think is great for us moving forward. Yeah, so I think that was it. I just wanted to finalize with some reflections that we have gotten throughout the year. So all of this might look complicated and be a bit daunting, but I do believe it has really made the life easier for us as a platform engineer. Instead of maintaining multiple systems that we did in the past, there was this on-prem infrastructure, we had this local development setups. We have tried to now standardize into one set of tooling. And something also to take with you is, yes, now our developers have gotten access to all this cool infrastructure, but then naturally cost spirals. So start from day one to work with cost. Use, for instance, tell your developers to use jobs rather than normal clusters. Use spot instances, have right fit hardware, and work with lifecycle policies if you are in S3, for instance. So there's a lot of one could do as a platform team to help out working with cost. Thirdly, also you should lean against Terraform and CI/CD. They are really your friends, and when it comes to setting up this kind of infrastructure and orchestrating it. Both making it simpler for you to track changes in your configurations, but also making it easier to test and have a high quality of the infrastructure. But then last, I think if there's one thing I think you should take with you, if you are like a platform team as myself, really work close with the users. Don't forget that. It can be easy to just sit back and say, here's some technology, use it. But I think the key for us and our success has been that we work very, very closely with our users and help them out in their challenges. So yeah, I think that was it. So thank you all for listening.